Chlorine gain one electron, it becomes chloride ion, it becomes 288. That is the same electronic configuration of argon, but it will acquire one negative charge. Why it will acquire one negative charge? Can you tell me? Because of extra electron. And why it is acquiring the positive charge? Because of losing of one electron. Okay, so one element is losing, another one is gaining, so they are acquiring a positive and negative charges, and this is the now they have become ions. Now they are the ions. Ions are those atoms that are acquiring a positive and negative charges. Okay, so what are sodium and chloride ions? Sodium ions are those that are acquiring the positive charge, and means any ion which is acquiring positive charge, it is called cation, or the positively charged ion, or any particles, any atom that is acquiring positive or negative charges by losing or gaining of electron, they form ions. And now it is happy. Now sodium is happy by losing one of its electron. It has nothing to do with chlorine now, because it has donated one electron and it is completely free to move. Okay. And similarly, chloride ion has accepted the one electron. Now it is nothing to do with sodium atom. They are happy. They both are having stable electronic configuration to the nearest noble gas. But here, they are still tightly hold together. Why? Because they are the opposite. They form a positively charged ion. And there is a strong electrostatic force of attraction between these two. Between these two, there is a strong electrostatic force of attraction between the two oppositively charged ions. Electrostatic force is the highest and the topmost force among all the forces that exist on the earth. Okay, so we can simply say here that sodium ion and chloride ions are the two oppositively charged ions, and they are holding together with a strong, very strong force of attraction, as a result of which they are tightly bounded. They are not free to move. One chloride ion, one positive ion. And this type of bond between the positive and negatively charged particle is called electrostatic bond. Electrostatic bond. And the type of compound, such compound is called ionic compound or electrovalent compound. It's called ionic compound. Type of such compound is called ionic compound. Understood, everyone? Yes or no? Type of such compounds are called ionic compound or electrostatic compounds. Okay, understood? Yes or no?
Yes.
So let you write this one, just a minute. That what are ionic compound? So ionic compound, and these are generally formed between metals and non-metals. Like metal loses electron and non-metal gain electron. But sodium chloride, sorry, ammonium chloride, which is having nitrogen, which is a non-metal, hydrogen as a non-metal, and chloride ion. This ammonium chloride is also ionic compound, but it is having all non-metals. So that's why we use it is typically, not every time. Most of the time it is between metals and non-metals. Okay, and this occurs between metals and non-metals. Okay, generally that's occur between, but it is also ionic compound between the, because ammonium ion has having positive valency and chloride ion having negative valency. That's why. So an ionic compound is a compound composed of ions held together by a strong electrostatic force. It is here we can say that written. The formation of ionic compounds are formed by the transfer of electron. One element transfer the electrons, another element gain. So it is actually transformation of electron between two atoms. One is losing, another one is gaining. Typically occur between metals and non-metals. Like metals have low ionization energy, they can easily lose electron, while the non-metals have high electron gain effective, and they can easily gain electron to form negatively charged ions. And for example, like sodium is losing one electron and chloride is accepting one electron, and now they are tightly hold together with a strong electrostatic force. Okay, they are tightly hold together with a strong electrostatic force of attraction, forming ionic bond. Okay, ionic bond. Understood? Yes or no?
Yes.
Okay. So here we can simply say that you have to first memorize this one. What are the ionic compound, and then you start writing. When you learn this one, let me know.
So that way should we learn?
Up to the whole page you have to learn.
Okay.
You can write it in your own words, not like exactly same word is being required. Means you have to memorize the main points. Okay. The
Okay.
art of writing and the learning something should be improved in your opinion. Okay. If you start copying this one, then you will you can copy this one just having your brains absent or you are thinking something else. But you when you memorize this one and you write in your own words, then it is using your brain to write it. Okay. That time your brain cannot think something else. Okay. When you are writing. And I will remove this one and you have to start writing it. Okay.
Okay.
Done. Memorized. Memorized.
Sir, 2 minutes can you give?
Okay.
Done.
Done everyone? Okay, start writing. Yes, you also Junaid, you memorized?
Yes, yes.
Start writing. What are ionic compounds? Done, everyone noted? Yes or no, fast?
Done.
Okay. Now, since the ionic compounds are held together with a very strong force of attraction between them, okay, and they are tightly bonded together, so large amount of force is being required to overcome this force of attraction. Okay, means they are tightly held together because you know that actually I have told you if I am showing you the ratio of the gravitational force and the electrostatic force. So we can simply say that electrostatic force is 10 raised to the power 39 times. Then 10 raised to the power 39 times greater than the a gravitational force between two bodies, mass object. Even you can see that your bag, which is you are carrying to the school, it is heavy. It is being attracted by the earth towards the center of the earth due to gravitational force. Imagine if this is being attracted by a charge sphere, it will be 10 raised to the power 39 times. It will be bigger than the force of attraction between these two will be means that you will feel your bag, only the bag, mass, weight, uh, as a weight of 2 or 2,000 earth, approximately 2 to 5,000 earth weight. So electrostatic force is very huge force. Okay, and when they are held together by a strong electrostatic force, So they are not free to move. That's why ionic compound do not conduct electricity in the solid state. They conduct electricity only in the molten or aqueous state. Okay. Why, if the question comes in examination that why do ionic compound do not conduct electricity in solid state? Because in solid state they are hold together with a strong electrostatic force of attraction. As a result of it, they are not free to move. And if they are not free to move, then what would happen? They cannot conduct electricity because ions, like for example, like in conductor, free electrons are required to transport to conduct electricity. Similarly, in electrolytes or in ionic compound, the ion should be the positively and negatively charged particle should move from one place to another place. And since they are tightly held together with a very strong force of attraction, they are not free to move. Understood? Yes or no?
Yes.
That's why ionic compound do not conduct electricity in aqueous or in molten state. Ayan, are you there?
Yes, sir.
Please turn on your camera.
Okay, sir. 1 minute.
Done? Understood? So they are held together with a very, very strong force of attraction. And similarly, ionic compounds are generally solid. I mean, they are generally means they are solid. All ionic compounds are solid. Why? Because of the strong force of attraction. Solid means the particles are not free to move. They are held together at particular positions at a particular time. They cannot change their position from one place to another place. So same thing happens here also, that when ionic compound, if I'm talking about the ionic compound, the ionic compounds, the ions are not free to move because they are held together with a very strong force of attraction. That's why they are not free to move. And since they are not free to move, they will not, they are solid state. They are in solid state. In liquid state, the particles are free to move now. If something is not free to move, it means it is solid. And why it is solid? Because of the strong electrostatic force. Otherwise, sodium has given its electron to the chlorine forever, and chlorine has accepted the electron forever. They both are happy. Sodium is having 2 electronic configuration, Na positive, by donating 1 electron. And chloride ion has accepted the electron. It is also having the electronic configuration to that of argon. It is also happy. But they are tightly held together because they are held together with a very strong force of attraction. Understood? So this is the reason. And ionic compounds are always soluble in polar solvent. What do you mean by the polar solvent, polar substance, polar compounds? Like there are some metals that have the polarity or they are considered to be as highly electronegative element in chemistry. And these are fluorine, then oxygen, then nitrogen, then oxygen, oxygen, and chlorine. These are the highly among the all elements. They are the highly electronegative elements. And what does it mean that if I'm saying that something is highly electronegative? It means that they have the ability to attract the bonded pair of electron towards itself. When they are bonded with some other elements, some other compounds, they have the ability to bond to attract the bonded pair of electron towards itself. Like for example, if I'm talking about H2O, water. So when according to the hydrogen has 1 electron and oxygen has 6 electron in its outermost shell, 1, 2, 3, 4, and 5, 5, and 6. 6. And 1 hydrogen is here. But actually, what does in this bonding, what does this is the bonding between hydrogen atoms, because hydrogen want to complete its 2 electron. Hydrogen has only 1 electron, so it want to have the helium electronic configuration that is of 2. So the duplet of hydrogen is being completed and the octet of oxygen is being completed like this way. But what actually the oxygen does here is that the oxygen attract this bonded pair of electron towards itself. Means it attract the cloud. Like for example, this is the cloud between the hydrogen atoms and the oxygen atoms. Electron cloud. Electron is revolving and they are forming the cloud. But what does the actual happen is that it attract the cloud like this toward itself. The more electron cloud shifted towards the oxygen because of its highly electronegative nature. it has tendency to attract the electrons, the electron cloud toward itself. Understood? As a result of which, since the hydrogen has the ability to attract the bonded pair of electron itself, the oxygen is going to have slightly negative charge, because anything that is going to have slightly negative charge or attraction power towards the oxygen, or any element is attracting the electron, it means electron is negatively charged. Like for example, you have fire. There is a fire. Okay, there are the two persons sitting A and B person sitting here, and the fire is lighting here. Okay, the fire is lighting. If this A person attract this fire toward itself, so it will be having, it will be facing more heat towards itself. Ayan, are you listening?
Yes.
Using phone? You are smiling. So are you smiling by your own? Looking into something?
No.
So here we'll say that this is the hydrogen. Actually, it should be like this, but the electron cloud distort and it is attracted more towards the oxygen, more towards the oxygen. It gets distorted more toward the oxygen and lesser toward the hydrogen. As a result of which, the electron cloud, since it shifted towards the oxygen, it becomes slightly negative, and since it is removed from this one, so it becomes slightly positive. And this OH bond in water is producing slightly positive charge on the hydrogen and slightly negative charge on the oxygen. And since the negative and the positive terminals are being induced on the ions, on the atoms of hydrogen and oxygen, these compounds are called polar compound. What we call them? Polar compound, because they have tendency to attract, to distort the electron clouds. They distort its shape and attract it towards itself. Okay. So as a result of it, this become polar compound. And like you see, polar, like you have NaCl crystal. Like I'm going to show you the NaCl crystal. NaCl crystal is just like NaCl crystal. NaCl has, like for example, NaCl crystal. You can see, you can take a crystal of NaCl, sodium chloride. You can check it that it is having much bigger inside that you can see it with naked eyes. Okay. But do you think that one crystal is going to have billions of Na positive and Cl minus ion? So, and they are hold together tightly with a strong force of attraction between them. So actually, if we dissolve it into the water, this is Na positive and Cl minus, and here is a water molecule. Here is a water molecule. This is the OH. This is the water molecule. So what? This is slightly negative. This is slightly positive, slightly positive. So what? This negative charge on the induced negative charge because of the distortion of electron cloud, or because of polarity difference, okay, or the more attraction power of the oxygen, this oxygen can attract the sodium ions from its crystals and break the crystal and split into Na positive and Cl minus ion. And here another hydrogen atoms of water, which is having the positively charged here and negative charge here, it will attract the chloride ion. And this is the way that how when you are adding sodium chloride to it, it become distorted, it become dissociated, it become positively and negatively charged ions, and they are free to move. So when you are adding sodium chloride to the water, we are not heating the sodium chloride. Otherwise, if you want to separate the Na positive and Cl minus ion, large amount of heat is being required. Large amount of heat is being required to break this bond. Okay, large amount of heat is being required to break this bond. But and approximately 2100 degrees Celsius temperature is being required. But if you even dissolve sodium chloride in the normal water, it can easily break into ions. Why? Because of this polarity of water molecule, because it is also applying the electrostatic force. Water is also applying the electrostatic force. So when they are the two electrostatic force, they will cancel out each other. One is the force between sodium chloride and sodium ion and chloride ion. Another one is water oxygen and the sodium ion. So they will break it. They will help in breaking it. That's why sodium chloride or the ionic compounds are soluble in the polar solvent. Like the water is a polar solvent. They are soluble in polar solvent. Understood? Yes or no? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So start writing the further properties of ionic compound. Just a minute. Here you please write the properties of ionic compound that they have. First you have to memorize this, then you have to start writing it. Okay.
Sir.
Yes, you done everyone. Noted.
Sir, I have a doubt.
Memorized. Junaid, memorized. Alvina, memorized.
Sir,
Yes.
what does polar solvents mean?
I was just explaining you polar solvent. Polar solvent means that are having those solvent that are having polarity difference, like oxygen and hydrogen. When they combine together, they distort the electron cloud. As a result of which, oxygen gets slightly negative charge and hydrogen gets slightly positive charge. And the poles are the positive and negative poles develop. Some compound that don't have the polarity difference, like carbon and oxygen. Carbon dioxide is not a polar substance. Okay, like if I'm talking about another substance like petrol, okay, like oil, okay, they are not the polar, they don't have polarity difference. Okay, so when oxygen, nitrogen, fluorine and chlorine, they are reacting with some other substance, not by themselves, like for example chlorine atoms, they are not polar. Why? Because they will attract, they have the same power. So one and another, they both have, they will not distort the cloud. When one is powerful, like for example, this is a tug of war game, there are the 5% and there is only 1%. So it will attract it's toward itself now. The same thing, when you have a powerful atom like fluorine by making bond with another hydrogen atom. So it will attract like the cloud of electron cloud should be like this. The same. Okay. But what actually happen is that fluorine and hydrogen, it attract the cloud toward itself. Is that when the electron cloud shifted towards any element, it got a negative charge and positive charge. And these are called poles. And these compounds are called polar compounds. Okay, like water is a polar compound.
Okay.
Done. Start writing. Noted if you have not noted. Start writing fast. Start writing fast, Alvina. Done.
No.
Noted fast. Done. Yes or no? Done?
Yes.
Check whether if you have done some mistakes. And the ionic compounds are arranged in a crystal lattice. I mean, they are not arranged like any substance can arrange. Okay, they are arranged like this way, like in a crystal lattice. Like this is a sodium ion, chloride ion. They are if you take any one crystal, there are so many lattice in that one. Okay, like sodium ion, they cannot arrange them. They are arranged in a proper pattern. Okay, that is called lattice. So they are arranged in a lattice like structure. Okay. So ionic compounds form a crystal lattice in solid state. This regular arrangement of ion result in well-defined geometrical shapes and contribution with high stability of the ion. Note it down fast. Done? Noted, Alvina and Junaid.
Yes.
Alvina, you also?
Yes, sir.
Okay. Now let's move further. Like for example, how if I'm talking that how the if I'm talking about the Lewis dot structure. Lewis dot structure is a representation of ionic compound, that how the electron transfer take place and how the actual electron transportation take place. Okay, so that we called it Lewis dot structure. Okay, Lewis dot structure. It helps us to identify that how the elements are combining together, or the two elements are combining together by joining or losing some electrons. Okay, like for example, if I'm in sodium ion, okay, sodium is going to have electronic configuration 281. Okay, 281, and chloride ion is going to have electronic configuration 287. So when one sodium ion is going to lose one electron, okay, because why? So only the outermost electrons should be there, that is going to lose that is means that is going to lose electron or gain electron. Only the outermost electrons are being represented in the electron dot structure or Lewis dot structure, and the electrons are represented either by dot sign or by cross sign. It's your choice whether you want to make it like this way or like the cross sign. Okay, and only the outermost shells are electrons are being represented, like Na will lose one of its electron. Okay, Na will lose one of its electron and will give it to the chloride ion, because chloride ion having 287 electronic configuration. So the first step is just to represent the outermost shell electron. Okay, like this way. The second step is is after donating. You have to represent the arrow that it is giving this one, and when it donates, you know that sodium and donate one of electron, its electron configuration will be 2,8, and it will be 288. But this sodium will acquire, what is the difference after losing and losing? So the difference is that it will become positively charged. And what is the difference in gaining one electron? It will become negative charge. If it gains one electron, it will acquire one negative charge. If it gains two electrons, it will acquire two negative charge. Okay. And the third step is that you are going to have, means you write it in the bracket and then it will be Cl minus N. Okay. So you understood the structure of sodium chloride.
Yes.
So should I remove it? And you will be able to draw the Lewis dot structure of, check it once. And then I'm going to remove this slide and then you have to draw the structure of sodium chloride. Okay. When are you in India?
No, sir, I came to Saudi.
Again. And you, Junaid?
I'm in UAE.
UAE. And you, Zainab?
Qatar.
Qatar. Oh my God, 3 different countries in a single platform. Qatar, Dubai, Saudi. Done?
Done.
You, Sayyid Alvina? Done?
Yes, sir.
Okay. Make the structure. Make the structure Lewis dot structure of sodium chloride.
Done.
Check whether if you have done some mistake. If you mentioned the electronic configuration before and after. Have you mentioned the charges, positive and negative sign? The brackets, and in the brackets, charges also. The negative charge and the positive charge.
Yeah.
And the outermost shell's electron of the negatively charged ion, like Cl minus ion. You done?
Yes.
Okay. Try to Note it down that Lewis dot structure is the foundational tool in chemistry to provide the visual representation of bonding arrangements of electrons in this one. Only this up to here.
Sir, I have an exam to give in 5 minutes. Can I leave?
What are you saying?
I have an exam to give in 5 minutes, maths.
So okay, draw the structure of magnesium chloride and magnesium oxide both.
Okay. I have already done this in the backup class.
You've done this one in the backup class now.
Yeah. You made the whole class write it.
Okay. Right, a Lewis dot structure, when it is being asked in the examination to draw, then you have to keep in mind that you are going to do this one in the 3 steps. You have to follow the 3 steps, okay? 3 steps. The first one is the representation of electron and the arrow, and the second one is the after transportation of when the electron is being transferred. You have to write this one, like for example, in the A step, the magnesium is going to have 2 electrons in its outermost shell and chlorine going 1, then it is donating one electron to each because chlorine can accept a maximum 1. So we require 2 chlorine atoms. Okay, then after donation, this magnesium will become 2 positive, this will become negatively charged, and this will, okay.
Okay, sir.
So do this one, please. Done. Noted.
Yes, sir.
The next one is the aquaregia. What is aquaregia? Can anybody in the class can tell me what is aquaregia? What is aquaregia? Aquaregia is a mixture of concentrated sulfuric acid and note it down. Aquaregia is also called royal water. It is a mixture of concentrated sulfuric acid, sorry, HNO3 and nitric acid and hydrochloric acid. This is the HNO3 is nitric acid, okay, and hydrochloric acid. So when we have nitric acid first and then HCl at last, okay, then its ratio should be 1:3. But sometimes it is in as 3:1. But in when it is 3:1, HCl should be written first and then HNO3 will be written later, okay. So 3 portion of HCl and 1 portion of nitric acid, concentrated nitric acid, when they are mixed together, they form aqua regia, which is also called royal water, and it is used to dissolve noble metals like gold and platinum. Okay, note it down fast.
Done, sir.
Okay. So that's all for today. We'll meet you in the next class. Thanks for coming, everyone. Okay.
Okay,